So I'll be showing you a few examples of the DFM Pro session within the Pro Engineer environment. The same kind of interface applies to other CAD systems as well. As we saw earlier, we can cover various manufacturing processes, including machining, sheet metal, plastics, assembly. For the medical equipment domain, plastics, sheet metal will be the most common processes which are used. So we will concentrate on those, and if time permits, we can see others as well. As you can see, DFM Pro is tightly integrated within the design environment. So as a designer, you can launch DFM Pro within your CAD system. When we launch DFM Pro, you can see in the input section, there are two inputs which are required. First is something which we call a rule file. This rule file contains the list of best practices and manufacturing guidelines which we want to check for this particular design. The second input is the manufacturing process. For this part, I'll be checking it for injection molding. So let me just select run and allow DFM Pro to proceed. Now, as you can see here in the graphics area, DFM Pro identifies a pulling direction and shows it to the user for confirmation. In addition to this direction, you can change it if required, or you can go ahead with the default selection. You can also specify a nominal wall thickness, or DFM Pro can compute it automatically. We'll go ahead with the default selections. Now in the background, DFM Pro starts by identifying the various manufacturing features on this model. So for this component, you have the nominal wall, the draft angles, ribs, bosses, undercuts. So all these features are identified. Based on the identified features and the rules which are specified in the rule file, DFM Pro will apply those checks, and any violations are then shown to the user on the screen. Now on the right hand side, we can see certain checks which have failed. Now these are executed based on the rule file which is selected and the appropriate rule parameters. In a short while, we'll see how we can fine-tune those parameters to suit your manufacturing requirements. When I click on the root node of a rule failure, you can see in the graphics area the corresponding instances are highlighted, and a brief message is shown at the top of the screen for the Pro E environment, which tells the user why this rule is important and what is the impact of not adhering to this rule. I can open up this root node in the tree and click on individual instances. Okay, so it will zoom into the specific instance and it will show me what's wrong with this instance, what needs to change. Again, in the message window, you can see that there's a brief message which tells the user what needs to change. So here we see that there is a radius which is missing at the base of the boss. So there's a sharp corner which can cause problems during manufacturing, cause stresses. Similarly, the next rule is related to uniform wall thickness. I can click on any given instance and it will show me that region on the screen using a green arrow in the graphics area, which tells the user at which region the thickness is not appropriate and needs to change. In the message window at the top, we can see the corresponding recommendation which says that the minimum wall thickness is less than the recommended value. Similarly, we can browse through other instances. Now, for each of these rules, we see that there are certain parameters which are checked for. For example, for the wall thickness rule, we have a recommended value for wall thickness, for minimum wall thickness and maximum wall thickness. Now these values may change based on your manufacturing conditions, materials, the kind of functional requirements you may have. DFM Pro allows users to configure these values very easily. Let's see how we can do that. Just beside the rule file, there is an edit button. If I click that, it's going to launch the rule manager. Now this utility allows you to configure all rules which are supported by DFM Pro. Here in the first column, we can see the rule name. To the left of every rule name, there is a checkbox. Now this indicates whether the rule is selected or not selected for execution. Now typically when an organization deploys DFM Pro, the first step is to select the rules which are relevant for the organization's manufacturing requirements. There will be some rules which are very important, which are critical to the manufacturer's manufacturing requirements, and there will be some rules which can be ignored. So the organization has a facility to turn off any rule which may not be important. Once the rule set is selected, the next step is to configure these rules as per your requirements. For example, the uniform wall thickness rule, I can just right click, select the configure rule option, and this is where I can specify what is the minimum and maximum wall thickness which we want to work with. Now you can either go ahead with the default recommendations or you can change it to suit your requirements. Similarly, you can configure these rule parameters for all rules which are supported by DFM Pro. In addition to these rule parameters, you can also set the criticality. Now whether a rule is critical in the manufacturing process, so if it's going to have a high impact on time and cost, you would treat it as critical, and if the impact is lower, you can then lower the criticality. In addition to this, you also have the facility to launch the help file, which will take you to the corresponding rule in the help document and show you why this rule is important, what is the recommendation. Once this rule file is set up, you have selected your rules. Each rule is configured, or you can use the default values. You can save the complete set as a single rule file, which is a file with a .dfm extension. Now this file can be selected for execution within DFM Pro. Now if I go back to the Pro Engineer environment, we can see that in the input section, there was a file called demo-pro-e.dfm. Now this file is the .dfm file which we are referring to. We can browse and select multiple such rule files. So you can see that the rule file is just a set of manufacturing constraints. You could have multiple rule files depicting multiple suppliers and so on. Now once you have these rules, you can execute them. Let's look at the other rules in the rule set. You have minimum draft angle check, where you can check for the adequate values of the draft angle in the part. You can check for different values on the cavity side or on the core side. Or we have recommended rib parameters rule, where you can check for the rib parameters, whether the rib height is adequate, whether it's too tall, whether it's too short, whether it is too thick. We have the mold wall thickness rule, where you can check for the clearance between various features. So in case you have features which are very close to each other, it's going to tell you that this is going to lead to a thin steel condition which can have problems during manufacturing. You can check for undercuts. So that if there are any undercuts which need side actions or moving cores, it will identify them for you. So these are some of the rules for injection molding which can be checked using DFM Pro. Let's look at one sheet metal example. Okay. The process remains exactly the same. You just launch the component, launch DFM Pro, select the appropriate rule file, select the appropriate process, and execute DFM Pro. Based on the process which is selected, DFM Pro will identify the corresponding features and then execute DFM Pro as per required. For sheet metal, the kind of features which would be identified include bends, flanges, cutouts, holes. Based on these identified features, the specified rules are executed, and then you can see such violations on the screen. Again, the interaction is exactly the same. I can click on the root node of the failure. The instances are highlighted in the graphics area. I can click on individual instances. I can right click on an instance, zoom to the particular instance, or I can right click, launch the help document. For sheet metal, the rules range from checks related to hole distance to bends, teardrop hem parameters, parameters of open hems. For example, you have a hem here which is having a very small radius. You can check for minimum bend radii for all the bends in this part. You can check whether the distance from cutouts to bends is adequate, or if the distance from slots to the boundary of the part is adequate or not. So all these checks can be performed with minimum configuration and at the click of a button. Typically, a designer would go through the design, reach a logical state, use the rule file, execute the checks, and then correct the design as required. Now, if as a reviewer, you would be interested to generate reports. So for doing that, we have the report generation facility. DFM Pro supports 3 kinds of reports. We have the eDrawings report, which is like a 3D report. We have the XML report, which is more static in nature and which provides an excellent summary of the analysis. And we also have the Excel-based report, which is more tabular in nature. Let's look at each of these reports. The Excel-based report, as you can see, is a tabular one. You can have your own logo in the report. Then it starts with a table which shows the summary of the analysis, how many rules were checked. I can click on any individual rule and it will take me to corresponding tab which contains more information about the rule. In this specific sheet, all the instances which have failed for this rule are listed with the actual values, and then additional columns are available for tracking this failure. So you can have action items, status of the analysis, any additional remarks till you track the item to closure. So this is available for all similar rules in this list. On the other hand, the 3D report is more interactive. All the instances which we saw as failures within DFM Pro are now transferred on the left hand side here. I can click on any individual instance and it will highlight the same in the graphics area. Okay, in the bottom left corner of the screen, you can see the corresponding message. So this file is now self-complete in nature. You don't need any additional CAD system. You just need a free eDrawings viewer to view this file.